Okay, so, oh. All right, ladies and gentlemen, we're going to get started. Yeah, okay. Yes. Okay. Question, whoa. Question number 1 is one of the more tricky ones on the assignment. It requires you to draw a picture and to identify on your graphs where your mean and your median would lay relative to each other. So, a couple of things to keep in mind. That, one, we want to draw a picture where we want our two distributions on the same axis so that we're comparing them on a similar plot, not one plot over here and one plot over here, okay? Secondly, we want to remember skewness is fewness. That will help us draw our two distributions, okay? And another thing to remember is that when we draw our distribution, here's an example of distribution 1, because it is skewed right, that the median will always lie closer to the peak. So if this is our skewed right distribution, then the median will lie to the left of our mean. So that's distribution 1. You want to draw a similar distribution for distribution 2 on the same axis so that they're matching up, and then you will follow along to your 5 different statements, seeing which of them are true or could potentially be true. Remember, there's a keyword. They're asking you which one is not true. Pay careful attention. This is not a lower level class where they're going to highlight those keywords or bold them for you. You need to read carefully and pick out what's important. Okay, moving along, question number 2. Question number 2. What? No, I'm not giving you answers. I'm just giving you some hints and strategies. The answers I will give tomorrow after school. Number 2, this is a weighted mean question. You're actually going to set up a simple one variable algebraic expression. Okay, you know what the mean weight of the men is, and you know what your proportion, what the total proportion of men makes up your sample. You know what proportion of women make up your sample, but you don't know what their weight is. That'll be the unknown variable. And you know that the weighted average is the sum of those two pieces, and you know what that is equal to. So again, it's going to be a simple one variable equation. You'll have the weighted mean weight for the men. You know both pieces of that calculation. You know the proportion of women that make up the sample, but you don't know what their weight is. That's the variable that you'll be solving for. And you know what that sum of the two weights will equal. Number 3, we have a box. Oh, so this is not in order for some reason. Okay. So number 3 is on the back. We have a box plot. Okay. Remember, we want to identify all our key pieces. I see the word in my answer choices skew, and they're talking about means and medians. So we definitely want to identify whether we have a symmetric or skewed distribution. And then we want to identify what that would mean in terms of the mean and the median. A couple of hints from the notes earlier today. If it is skewed right, you'll have a longer tail on the right, and your mean will be greater than the median. If it's skewed left, you'll have a longer tail on the lower end, and your mean will be less than the median, remembering that the mean is always pulled in the direction of the skew. The only other piece of that is the interquartile range. Remember, the interquartile range will be a single value that we get by calculating Q3 minus Q1. And just to help us clarify, we have our minimum, we have our Q1, we have our median, our Q3, and our maximum. Okay. About the tail. So going back to skewed right means that there will be a long right tail. Skewed left means that there will be a long left tail. A track athlete specializing in the long jump has a median jump of 6 meters with an interquartile range of 1 meter. What are the median interquartile range of the athletes jump in yards, given that they're about 1.1 yards per meter? What are they asking me to do here, ladies and gentlemen? A linear transformation, right? We are going to add or subtract, multiply or divide by a constant. So what is it that they're asking us to do? They give us our results in meters, and they want us to change it to yards. To go from yards to meters, we multiply by 1.1. So we need to think back to what variables, what measures change when we multiply or divide by a constant. Okay? So the question here really becomes, what measures change or stay the same when we multiply by a constant? I'm not going to tell you. It should be in your notes. Okay. Alrighty. Next. Which of the following statements are true? Okay, remember, we're going to see a bunch of these. 1, 2, and 3. And 1 only, 2 only, 1 and 3 only. Okay. Categorical variables are the same as qualitative variables, so we need some vocabulary here. Categorical variables measure characteristics that are not quantitative. Okay? Qualitative variables categorical variables and quantitative variables. Well, I know quantitative variables. Quantitative variables are numbers, and they can either be whole. If they're whole, we call that, no, discrete, or they can be, so we have data, right? We have a variable. The data can either be categorical or quantitative. And then from quantitative, it can either be discrete or continuous. Remember, discrete means it has definitive starting and stopping points. Usually they're whole numbers, though they don't have to be. It could be counting by 0.5s, 0.25s. It just means that there is some break in between your counting pattern. Thanks, Elliot, for the boost count. 7.5. Well, it's 7.5 isn't really anything. It's how you measure it. So okay, so continuous is something that you would measure in, there's no boundaries to how far you can break it down. So the time it takes to do something, time is a continuous random variable, always. Okay, because you can break it down to seconds, milliseconds, whatever breaks down beyond that. Okay, exactly. But things that are counted in whole numbers can't get any more specific than the whole number. So typically discrete are the number of A's you got. You got 1, or you got 2, or you got 3. You can't get 1.23. Okay? Or, yeah, the objects are always discrete. Okay? You have them. Okay? There are possible to have 0.5s and things like that and still be discrete. It's just I'm not coming up with something right off the top of my head. Okay. Next problem. A sample consists of 4 observations, 1, 3, 5, 7. What is the standard deviation? Do not even think about calculating this by hand. You should be using your calculator, putting your data into L1, running stat calc 1, and getting your one variable statistics. Question, do we want S sub x or do we want sigma sub x? There's a key word that you have to identify to know. Sample. It tells us it's a sample. So which is the correct standard deviation? S sub x. We want a sample standard deviation. Okay? Remember, if you were to be dopey and do this by hand because you don't have a calculator at home, when you divide, you would divide by, yes, you would divide by n minus 1. Okay? But everybody here at least, is brilliant and has a calculator at home, so they won't need to do this by hand. And last problem. Oh, so there's one more after this? No, we did do number 2. There's one hint that I'm going to give you this. Standard deviation requires knowledge of one or more population parameters. Okay? The standard deviation requires knowledge of one or more population parameters. I'm on which of the following statements is true? It's the bottom question, the last question on the front. So for that question, the only hint I'm going to give you is standard deviation requires knowledge of one or more population parameters. That concludes the